हेलो अस्सलाम वालेकुम। होपफुली आवाज आ रही है सारों को। तो हमने आज ना एक टॉपिक वी हैव टू डू अ टॉपिक व्हिच इज रिएक्शन, रेट ऑफ रिएक्शन। ठीक है, वी नीड टू डू एंड कवर दिस टॉपिक वेरी वेरी क्विकली। रेट ऑफ रिएक्शन, अच्छा, सो व्हाट इज रेट ऑफ रिएक्शन? इट्स रेट इज बेसिकली स्पीड, सो इट्स बेसिकली हाउ फास्ट समथिंग हैपेंस। ठीक है, एक सेकेंड ना मैं, अच्छा, सो इट्स बेसिकली हाउ फास्ट और क्विकली something happens, a change happens. So how quickly, एक सेकेंड लेना मुझे। अच्छा, so how quickly something changes. ठीक है, that's what rate है. Now the thing is, the issue is कि your rate is dependent on change, how quickly that change is happening. Or change क्या है? What is change? The change in a chemical reaction, it could be any change. Now when it's a sprinter that's running, तो उसमें क्या होता है कि the sprinter is running, it's covering a distance. So the change that is measured when a sprinter is running is distance. That is what is changing. I said, लेकिन what happens in a chemical reaction is that what is changing, it could be a lot of things that could be changing. It could be the mass of a substance that is changing. So how quickly that mass is changing, that could measure how quickly the reaction happens, right? Okay, if you have something that weighs 10 grams and in 2 seconds it weighs 5 grams, so that means the change is happening very, very quickly. If the same change happens and takes like 50 seconds or 2000 seconds, then that change is going to be very, very slow. So the mass of a substance could be changing in a chemical reaction. The volume of a gas could be changing in a chemical reaction. और क्या हो सकता है? It could be the concentration could be changing. Lots and lots of things can be changing. It could be the number of bubbles that could be changing in the reaction. What else? It could be a color change as well. So how quickly does the color change? If it happens very quickly, the reaction is fast. If it happens very, very slowly, the reaction is going to be slow. What else? Can we think of something else? Something else changing in a chemical reaction. So we can have क्या हो सकता है? और क्या हो सकता है? Uh, Asif, कोई idea? Any option? Any other option? Like what else could be changing? We can have मतलब वॉल्यूम भी हो गया, गैस भी हो गया, color change, lots of things happening. So we leave it up at this. ठीक है, you can think of other changes that could be happening when a chemical reaction takes place. एक मेरे ज़हन में भी है. Uh, how quickly something dissolves. ठीक है, that is one thing that could also be measured with respect to. And remember, this is going to be with respect to time. So time is important because time is going to tell you whether it's happening quickly or whether it's happening slowly. So मैं क्या कर सकता हूँ? I can come up with a rate formula which is how quickly the change happens with respect to time. तो ये नीचे ना time है. Now normally time is going to be in seconds, but it could be in minutes. ठीक है, वो it depends, Cambridge के ऊपर depend करता है कि वो क्या ले रहे हैं. ठीक है, but it could be in minutes. It could be in hours as well if the reaction is like really really slow. So you can normally it is not, लेकिन who knows. ठीक है, और change all of the above. It could be any change. So that is rate. So I'm going to come up with a chemical reaction. We can try and figure out how to measure the speed of that particular reaction. So for example, I've got Mg reacting with किस साथ react करे? Let's say it's reacting with HCl. And when it reacts with HCl, what happens is कि वो क्या produce करता है? It produces MgCl2 and H2 gas is given off. So that's a solid. This is aqueous solution. Chlorides are soluble salts except for silver and lead. though this is soluble as well, and H2 is a gas. So when you see this reaction, let's say this reaction is happening in a beaker. So let's say that's my beaker, and this is ये जो है ना, this is my HCl solution. So I've got HCl aqueous, and I'm going to add a few pieces of magnesium to it. So let's say this is a piece of magnesium that I've added. ठीक है, I've added it into the solution. So what change would I measure with respect to time? So I can figure out, I can take out my stopwatch. ठीक है, remember time कितना measure होगा? That's going to be measured using a stop clock. ठीक है, keep that in mind that a stop clock is essential for measuring the rate of reaction. So in this reaction, how can I figure out what the rate of the reaction is? So I can measure how quickly this piece of Mg dissolves. So with respect to time, I can do that. What else can I do? I can maybe I can measure the change in mass of Mg. For example, every 20 seconds. Every 20 seconds, मैं क्या करूंगा कि I'm going to go in and I'm going to take out this piece of Mg and I'm going to wait. So the mass of Mg is going to decrease. I think it's going to decrease very, very slightly, but it will decrease, right? So I can plot a graph of that. So what else can I do in this reaction? I guess I can measure the pH of the solution as well because it's acidic. So what I can do is I can try and measure the concentration of HCl. How quickly does the concentration of HCl, how quickly does that get used up? OB, for example, every 20 seconds. And how can I measure the concentration of HCl? There are a couple of ways. You can either measure the pH because it's an acid. So the pH gives you an idea of how concentrated the HCl is. If the HCl gets used up, the solution is no longer going to be acidic, and the pH would come down to 7, right? It will increase to 7. Or wire titration. You can you can measure the quantity or the concentration of HCl. What you can do is every 20 seconds you can take a small sample of HCl, titrate it, and figure out what's the concentration. So as it gets used up, the concentration of HCl will decrease slowly and slowly. So what else I can do is that when I add this piece of Mg, I'm going to immediately start seeing bubbles of H2 gas getting produced. So if it's possible, I can count the amount of bubbles forming. Okay, so for example, again, example is that you do it every 20 seconds. You try and count, maybe you can take a picture and you can count the number of bubbles. So as the reaction proceeds, if the reaction becomes slower, the amount of bubbles will decrease. So that will give you an idea about the amount of bubbles that are getting formed per unit time, right? And so lots of things can happen. What else I can do is, okay, let me just add a few pages, 1 second. So the next thing that I can do is I can collect the hydrogen gas that is being produced. Okay, so there is obviously H2 gas that's getting produced. So I can collect that H2 gas. Now, if I want to collect that H2 gas, remember you'll be asked to draw the apparatus as well for that. So that requires a conical flask. Okay, so let's say this over here is my. Okay, now let me just very quickly try and make a drawing of a conical flask. So, okay, so that's a conical flask. And what I can do is I need to add a measuring syringe. Okay, so there's this measuring syringe, and this, yeah, this is my measuring syringe. Yeah, but let me. Okay, now it looks more like a measuring syringe, and we can have the reaction going on inside. So there's this tube that is going to be used to collect. Okay, that's going to be used to collect the H2 gas. So as soon as the H2 gas gets produced, ठीक है, so as soon as the H2 gas gets produced, इसको थोड़ा सही कर लें. The H2 gas is going to be collected over here. Well, there has to be a rubber bung, so you need to stopper this at the top. ठीक है, so our tube is stoppered. It should be, the whole apparatus should be airtight. They're going to cut marks for you if you don't draw it properly. So there's a rubber bung that I've put in place. And now finally, the solution is HCl. Okay, and that's incorrect as well. Slightly incorrect because I won't be able to collect H2 gas. So what I'm going to do is that this needs to be shorter. Okay, so this tube over here, it has to be shorter. Anyway, so our drawing is almost complete. So here's my HCl aqueous. Now, how do I add Mg to HCl aqueous without opening because it's an airtight apparatus, so I can't put Mg inside it. I would have to open it. Now, I told you that if you want to collect H2 gas, none of it should escape. So the apparatus has to be completely airtight. You don't there shouldn't be any gaps over here. So there's no space where I can add Mg. So what I'm going to do is I'm going to put Mg beforehand inside the apparatus in a tube. And so the Mg is already part, it's placed inside the apparatus before I seal it. And this one second. So the Mg is already placed inside beforehand, but in a tube. So that means it's separate from the HCl. So what I'm going to do is, if I want to start the reaction, what I'm going to do is I'm going to shake the tube. I'm going to airtight seal it completely with the rubber bung, and then I'm going to take this tube and tilt it. When I tilt it, what's going to happen is that the Mg is going to. So I'm going to write this down. That shake or tilt the apparatus. So tube containing Mg falls into falls into HCl. And that would start the reaction. That's when you're going to start the stopwatch. So that's how you're going to draw the apparatus. If they're going to ask you how to measure the rate of the reaction. So I'm going to add this method, which is that you can also measure the rate of the reaction by measuring the volume of gas. प्रोड्यूस्ड। ठीक है। अच्छा चले, so what I've done is I have the same reaction, Mg plus HCl, and I've told you multiple ways in which I can measure the rate of the reaction. ठीक है, वो रेट के you measure any change with respect to time. ठीक है, इसको हाईलाइट भी कर लेते हैं. Any change with respect to time. So this is what rate is. So Mg plus HCl. So multiple ways you can figure out how the speed of the reaction is going to be measured. कि how quickly Mg dissolves, that's one. एक से इसको. अच्छा, so how quickly Mg dissolves, that's one. फिर अगला क्या है, that's you can measure the mass, change in mass. हर थोड़ी देर बाद ना what you can do is you can take out Mg and you can measure the mass, कि how much of the mass has decreased. You can measure the concentration of HCl. You can titrate it every 20 seconds, every 10 seconds, maybe every 30 seconds. You can take a sample of HCl, do some titration, and figure out or measure the pH using a pH meter. That would also tell you the concentration of the HCl. You can measure the amount of bubbles, which would be pretty hard. How many bubbles are forming with respect to time. And you can also measure the volume of gas that's going to be produced. For that, you would have to come up with a different apparatus because you would have to collect the H2 gas that's getting produced. So पिछला वाला apparatus जो था, that's not going to work because उसके अंदर जो gas थी ना, that's all kind of escaping. So airtight rubber bung, you have to make it. So remember, the first question is going to be about drawing, and it's going to be either one of those. ठीक है, एक और चीज मैं I'm just going to add, since we were talking about changes. Uh, color changes, ये bubbles वगैरह, I mean both these examples that I did was sufficient for most experiments. ठीक है. For color change, remember there's a device. How do you measure color change? There's a device called the colorimeter. So if there's ever going to be a question where you want to figure out the speed of a reaction or the speed at which a color changes in a reaction, so you use a colorimeter. उन्हें कहना colorimeter से I was able to measure uh, the color of the change in color of the solution with respect to time. Achha, now what do you do with this? Uh, there are two things you can do. So how to measure rate? Now our experiment, let's say, is done. So how do we measure rate? So the first thing is once you're done with the experiment, right? Remember वो हमने क्या कहा था? Rate is what? It's proportional to the change that you're trying to measure with respect to time. कि how quickly is that change happening? ठीक है, we already wrote that down. Now इसको हाईलाइट भी कर लेते हैं. अच्छा, that's what rate is. Now the question is, कि once you're done with the experiment, so what are you going to do with that experiment? So what you're going to do is you're going to make a graph. ठीक है, ये वाला नहीं. अच्छा, so once you're done with the experiment, you're going to make a graph. On one side of the graph, you write what is the rate that you're trying to measure. ठीक है, उस रेट को आप मेजर करोगे और जो दूसरी साइड होगी ना वहां पे you'll be measuring time, right? So for example, your not rate, sorry, let me correct this. इधर आप change लिखोगे जो भी आप measure करो, and the other side you're going to write time. So for example, you're measuring the volume of gas, volume of H2 gas. So the volume of H2 gas would be something, वो कुछ इस तरह का आएगा ग्राफ. ठीक है, it's going to be something like this. That initially there's going to be a lot of volume of H2 gas that's going to be produced with respect to time. तो बड़ी तेजी से ना the reaction will, there's going to be the volume of H2 gas will increase. ये जो आपकी syringe होगी ना, इसके अंदर क्या होगा? A lot of H2 gas is going to be produced. And let's say every 10 seconds, every 20 seconds. Let's give it a hypothetical value. ठीक है, for example, every 10 seconds, 20 seconds, हर 10 second बाद 30 seconds, ठीक है. You are trying to measure and so on. ठीक है, you're trying to measure the volume of gas. And you plot all these points. ये plot हुआ, ठीक है, ये plot हुआ. This one, ठीक है, you're plotting all these points. तो आसिफ, अब इसमें ये कि the H2 gas will increase and slowly the reaction slows down and then it becomes constant. The constant straight line indicates that the reaction has stopped. So horizontal line shows that the reaction has stopped. That shows that there is no more H2 gas getting produced. Or your horizontal curve, it probably became horizontal at this point. Okay, this is the mark where you would know the reaction stops. So why does the reaction stop? Because the reactants get used up. Okay, that's why the reaction stops. I said now you've made the graph. What is the rate? So the rate of the graph, remember, when you plot change with respect to time, so the rate of the graph is your tangent. Okay, let me. So the rate of the graph is your gradient. So remember this. बल्कि ऊपर ही लिख लेते हैं, the rate of the graph is the gradient of the graph. ठीक है, the steeper it is, that means the faster it is. The faster the change is happening. So if the H2 gas rises very quickly, the volume of H2 gas gets produced. So you've got a very steep tangent, a very steep slope. That means the reaction is happening very, very quickly. लेकिन अगर वो slow होगा, that means the reaction is very, very slow. So keep this in mind. Steeper means it means faster reaction. Less steep means, so if it's less steep, so that means it is a slower reaction. ठीक है, ये याद रखा ग्राफ के अंदर ना, whenever it's steeper, when you plot a change with respect to, इसको फिर से हाईलाइट कर लें, when you plot any change with respect to time, तो जितना steep होगा, that means it's faster, and the less steep it is, that means it's slower. And the rate of the reaction is not constant. ठीक है, जैसा वो runner होता है ना, 100-meter race, he runs very quickly the first 10, 20, 30 meters, then he starts slowing down. Okay, so the reaction kind of behaves in the same way. It's normally very fast in the beginning. Then what happens? The reactors get used up. Then it becomes slower and slower. Then becomes constant when the reactants have completely gotten used up. Okay, तो horizontal का याद रखना कि the reaction stops. So normally reactions are fast in the beginning, right? They're very fast at the start. Think of कि आपने you're pouring a can of Pepsi into a glass. You see a lot of bubbles forming, right? It's very fast in the beginning and then it starts slowing down. Okay. So normally reactions are fast at the start and then the reactants get used up. So the reactants they start getting used up. And if they get used up, you're going to have less frequent collisions. You don't have a lot of reactants. we're going to come to collisions later on. So you're going to have less frequent collisions and the reaction would slowly become slower. So the reaction, it slows down. So when it slows down and eventually stops. Now, this is the profile of most reactions. Most reactions, they kind of behave in this way. Most of them, not all of them. Some of the reactions you have like autocatalytic reactions. Uh, so most reactions, so remember this is normally what's happening, right? So this is normally what's happening. There are a few exceptions to this. ठीक है, those few exceptions are, so few exceptions. An example for that is autocatalytic reactions. अच्छा ये क्या होता है? What's a autocatalytic reaction? It's a reaction in which the product is the catalyst. Remember, the catalyst speeds up the reaction. तो होता ये कि इसमें what happens is the product is formed. So initially the reaction is very slow, but then the product gets formed, and when the product gets formed, the reaction speeds up. तो वो बाद में it speeds up because the product is going to be formed later on. So which is why the product will speed up the reaction. So the reaction becomes faster later on. There's another example as well over here, which is reactions of aluminium. They are slow at the start, and then they speed up. So why are they slow at the start? Because they have an oxide layer that protects it. तो aluminium का जो मसला होता है ना, like if you take a piece of aluminium, so let's say this is the piece of aluminium. The problem with aluminium is that it's got a coating. It's got this coating of aluminium oxide on top of it, which is very non-porous and very unreactive. So we'll start with the reaction is very slow because the coating on top of it, it does not really react. It takes time for it to dissolve, and when it dissolves, then the aluminium starts reacting. So reaction becomes faster later on. Like normally, what happens is the reactions are fast at the beginning, at the start, and then they start getting used up. The reactions get used up. You get less frequent collisions, and the reaction slows down, and eventually it stops when all the reactants have gotten used up. So okay, ये तो this is one example. I've plotted the graph of a change with respect to time. And the change that I plotted over here was volume of H2 gas with respect to time. मैं कोई और change भी कर सकता था यहाँ पे. I could have plotted the change in mass with respect to time. अच्छा वो mass, now the change over there is a decreasing change. Mass जो होगी वो ऐसे ऐसे कम होती जाएगी, ठीक है? Like every 10 seconds I take out the magnesium and I try to figure out what the mass is. तो उसका जो graph होगा ना, that would kind of look like this. तो उसका भी graph बना लेते हैं. So now the change I'm plotting is the change in mass of mg, or simply the mass of mg, with respect to टाइम. अच्छा इसकी चेंज होगी, शुरू में मास ज्यादा होगी और फिर आहिस्ता आहिस्ता इट विल स्टार्ट टू डिक्रीज. तो इट वुड बी समथिंग लाइक दैट कि the mass of magnesium pieces that you added, they start reacting, they start dissolving, their mass decreases, and then maybe the reactions get used up and the reaction stops and nothing happens TK after that. So so the change could be increasing or decreasing. So the graph could be going upwards, like the one over here, जिसका वॉल्यूम ऑफ H2 गैस जो था वो ज्यादा होता जा रहा था, ठीक है, इट कुड बी एन इंक्रीजिंग चेंज, ज्यादा से ज्यादा H2 गैस बनी जा रही है. Or maybe the reactants get used up, so the mass of Mg starts decreasing. So the change could be increasing or decreasing. लेकिन बात वही है कि स्लोप, we just focus on the slope. ठीक है. More steep, that means faster reaction. So the same rule applies. Even if it's a decreasing change, more steep, more gradient, that means you have a faster reaction. वो gradient बना भी लेते हैं कि ये शुरू वाला gradient क्या है, that's ये gradient है. ठीक है, let me move that a little bit. हाँ. And then slowly what happens is that the gradient decreases. Yeah, let me fix that. हाँ. So slowly what happens is the gradient decreases. तो ये indicate कर रहा है this line over here. This means faster. Why? Because it's steeper, ठीक है. This over here, that's slower. Why? Because it's less steep. ठीक है. So you can figure out what the rate or what the speed of the reaction is based on whether the gradient is fast or whether it's slow. अच्छा, तो बस एक समरी कर लेते हैं. ये फर्स्ट लेक्चर है, ठीक है. अगले लेक्चर में हम रेट का डिटेल कर लेंगे. सो द समरी इज कि व्हाट इज रेट, ये हाउ क्विकली अ चेंज हैपेंस. व्हाट इज द चेंज? केमिकल रिएक्शन में कोई भी चेंज हो सकती है. कुड बी anything that is happening in the reaction where you can measure the change. It has to be a measurable change. तो आप क्या करते हो? रेट और चेंज वर्सेस टाइम, राइट? हाउ क्विकली दैट चेंज हैपेंस. तो ये मैंने एक रिएक्शन दिया था, तो उसके अंदर मल्टीपल वेज यू कैन फिगर आउट व्हाट, और यू कैन मेजर द चेंज. Mg कितनी देर से डिसॉल्व हो रहा है, कितनी जल्दी डिसॉल्व हो रहा है. व्हाट इज द चेंज इन मास ऑफ Mg, व्हाट इज द कॉन्सेंट्रेशन ऑफ HCl, how is that changing, what is the amount of bubbles changing, ठीक है, that could be measured. Volume of H2 gas, इसको जरा कलर भी कर लेते हैं एक सेकेंड. अच्छा, तो ये भी खैर आप चेंज कर सकते हो, ठीक है. एंड अच्छा, देन यू हैव टू you should know how to draw the apparatus, ठीक है. वो हाउ डू यू मेजर द रेट, के वो जब एक्सपेरिमेंट कर लिया, व्हाट आर यू गोना डू? यू गोना ड्रॉ ग्राफ. The volume of H2 gas कुछ इस तरह का होगा. It will increase. There's going to be H2 gas getting produced. Height जो है ना, that's volume, right? So it will increase with respect to time, and then it will become constant. उसका मतलब reaction रुक गया, ठीक है. So what will indicate the reaction is fast? The steeper it is, ठीक है. What will indicate that the reaction is slow? If it's not very steep, मतलब टाइम ज्यादा लग रहा है, वो slowly प्रोड्यूस हो रही है, ठीक है. सो फॉर एग्जाम्पल, इफ आई मेक अनदर ग्राफ, और वो वाला जो ग्राफ है ना, दैट इज ऑफ अ स्लोअर रिएक्शन. इट कुड बी स्लो फॉर अ नंबर ऑफ रीजंस, ठीक है. सो that's a graph of a slow reaction because it's less steep. ठीक है. वो पहला वाला जो रेड वाला था, वो ज्यादा जल्दी ऊपर जा रहा था. that was a faster reaction. ठीक है. So the red one is the faster one. The blue one is ये slower वाला है, ठीक है. और normally reactions मैंने कहा always they faster in the beginning, And I also told you that the change that you're trying to measure, it could be an increasing or decreasing change. So uh, उसमें भी आपने steepness देखनी है, that said. अच्छा, I'm just going to add one more point is how to measure rate. अच्छा, how do we measure rate of a reaction without drawing a graph? तो ये without graph है, ठीक है, without doing any measurements. तो how does वो 100 मीटर रेस होती है ओलंपिक्स में, how do they actually measure the speed of reaction? वो क्या करते हैं कि they don't draw any graphs. Usain Bolt is running, no one is making a graph or no one is doing any calculations or they're not even measuring the gradient, right? They're not doing that. वो क्या करते हैं? They're doing exactly the same thing except without a graph and without any calculations. Rate क्या है? It's change with respect to time, right? तो तो आप क्या करो, चेंज को कांस्टेंट कर लो. आई मीन कीप चेंज कांस्टेंट. फॉर एग्जांपल इफ द वो 100 मीटर रेस है ना, वो चेंज दे कीप द चेंज कांस्टेंट. फॉर एवरी रनर इट्स 100 मीटर्स, राइट? सो व्हाट दे डू इज दे कीप चेंज कांस्टेंट, उसको फिक्स कर लेते हैं. सो फॉर एग्जांपल इन आवर केस, वो जैसे 100 मीटर रेस है ना, एवरीवन हैज टू run 100 meters. That's the change that everyone has to accomplish, right? तो हमारे केस में एक्सपेरिमेंट्स में क्या होगा, लेट्स से the volume of just how H2 gas was getting produced. So I can say कि I'm going to try and measure कि how quickly 10 cm cube of gas gets produced. That's my change. In every experiment, I'm going to try and figure out by what is the amount of time that's going to take to produce 10 cm cube of H2 gas. So in that case, if the change is constant, so your rate is basically inversely proportional to time. That's it. तो आप बस टाइम मेजर करो. You don't have to measure the change. You don't have to do any calculations. If you're keeping the change constant, ठीक है, रिमेंबर कि अगर मैं वापस जाऊँ ना, 10 लोग एक्सपेरिमेंट्स कर रहे हैं और सबको ना, आई एम जस्ट गोइंग टू गिव देम अ टास्क. द टास्क इज कि मतलब एवरी 20 सेकेंड मेजर करना बंद कर दो. आपने सिर्फ ये करना है कि अगर इफ यू आर ट्राइंग टू मेजर द वॉल्यूम ऑफ गैस, forget measuring it every 10 seconds or 20 seconds. So all you can do is बस टाइम नोट करो कि take a stopwatch and note down the time कि what is the amount of time it takes for 10 cm cube of H2 gas to form. That's it. तो वो सिर्फ एक ही टाइम मेजर करेंगे. And in that case, since I've kept the change constant in each experiment, तो चेंज को लिखने की जरूरत ही नहीं क्योंकि वो तो कांस्टेंट है, राइट? सो रेट इज बेसिकली प्रोपोर्शनल टू 1/time, राइट? लेस टाइम मींस फास्टर रिएक्शन. मतलब वो 100 मीटर रेस वाला एग्जांपल है. इफ इट्स लेस टाइम, दैट मींस फास्टर. एंड इफ इट्स गोइंग टू टेक मोर टाइम, तो दैट मींस स्लोअर रिएक्शन. अब नॉर्मली आप बचपन से इसी तरह स्पीड, जब रेस भी लगाते हो आप इसी तरह मेजर करते हो. आप नहीं बैठ के वो ग्रेडियंट, ना तो आप ये ड्रॉ करते हो, ग्रेडियंट्स ड्रॉ करते हो, ना ग्राफ्स ड्रॉ करते हो. आपके दोस्तों के साथ रेस लग रही है, सो यू डोंट ड्रॉ दीज ग्राफ्स, ठीक है? यू डोंट उनके पे ग्रेडियंट्स वगैरह कैलकुलेट नहीं कर रहे होते हैं. व्हाट यू डू इज यू सिंपली डू दिस. तो लैब में भी आप जाके सिंपली ये कर सकते हो, अनलेस यू वांट टू फिगर आउट द स्पीड ऑफ द रिएक्शन एट एवरी सेकेंड. मतलब ग्राफ्स गिव यू अ लॉट मोर इंफॉर्मेशन. मतलब वो आपको बताते हैं कि भी ये इस टाइम के ऊपर ना द ग्रेडियंट वाज दिस, इधर जो टाइम था ना उसके ऊपर द ग्रेडियंट इज दिस, राइट? दे टेल यू व्हेन द रिएक्शन, मतलब तो ग्राफ्स गिव यू अ लॉट ऑफ डिटेल. सो ग्राफ्स आर ऑलवेज बेटर, बट शॉर्टकट ये कि बस सिंपली टाइम मेजर करो, लेकिन उसके लिए चेंज फिक्स होनी चाहिए. मतलब इट डजंट मेक सेंस कि एक बंदा 100 मीटर्स भाग रहा है और दूसरा बंदा 200 मीटर्स भाग रहा है, तो उनके टाइम मेजर करने का फायदा कोई नहीं है. आई मीन यू कांट कंपेयर द टाइम, राइट? So when you're comparing experiments, it's pretty important that the change has to be fixed. हर किसी को ना it should be the same exact amount of change that उसका time आप measure करो. And finally, what you're going to have is कि भाई less time है तो faster reaction है और ज़्यादा time लग रहा है तो it's a slow reaction. चलिए फिर lecture 2 के अंदर ना we'll do the factors that affect the rate of reaction. और फिर lecture 3 में we'll do past paper questions.